Chapter 10.1, Sums and Differences of Functions. We already know that we can perform mathematical operations on numbers and variables. We can do addition, subtraction, multiplication, and division. We can also perform mathematical operations on functions. For addition and subtraction, there's two different ways that we can express the sum or difference of two functions. The first way is to write h of x, our new function, equals f of x plus g of x, so the sum of the two functions. The other way is to write h of x equals bracket f plus g, and then outside the brackets we have x. These two things mean the same thing, they're just written in different ways. And then subtraction, we can do the same. H of x equals f of x minus g of x, or we can do h of x equals f minus g of x. Consider the function f of x equals negative 4x minus 3 and g of x equals 2x squared. Part A, determine the equation of the function h of x equals f plus g of x, so the sum of the two functions. H of x equals f of x is negative 4x minus 3 plus g of x is 2x squared. Because we're adding, we can drop these brackets and combine like terms if there are any. In this case, there aren't. I'm just going to write this as h of x equals 2x squared minus 4x minus 3. So I just put it in descending order of degree. Part B, is the function f plus g of x the same as g plus f of x? And is this always true? So does the order of addition matter? Is 3 plus 5 equal to 5 plus 3? Yes, they're both equal to 8. So yes, the functions f plus g of x and g plus f of x are the same because the order of addition doesn't matter. Part C, sketch the graphs of the functions f of x, g of x, and h of x below. Use the table of values to assist you. F of x is negative 4x minus 3. Let's plug in the values. We have negative 2. So negative 4 times negative 2 minus 3 gives us 5. Negative 4 times negative 1 minus 3 gives us 1. Negative 4 times 0 is 0, minus 3 would be negative 3. Negative 4 times 1 minus 3 should be negative 7. And then negative 4 times 2 minus 3, negative 11. Let's draw that graph f of x. We have x equals negative 2, y equals positive 5, x equal to negative 1, y equals positive 1, x equals 0, y equals negative 3, x equals 1, y equals negative 7, and x equals 2, y equals negative 11. We can join our points with a line. And that's f of x. Next, let's calculate the values for g of x. negative 2, 2 times bracket, negative 2, close bracket, squared gives us 8. Negative 1, that'd be 2 times 1. So 2, 0, 2 times 0 is 0. 1, 2 times 1 is 1. And 2, 2 times 2 squared would be 8 again. Can plot those points. When x is negative 2, y is positive 8. When x is negative 1, y is 2. When x is 0, y is 0. When x is 1, y is 1. That should not be 1. That should be 2. When x is equal to 1, y should be 2, because we have 2 times 1 squared. Okay, so we'd have x is 1, y is 2. So it needs to be symmetrical from the point negative 1, 2. And when x is 2, y is 8. We have a parabola. Something like that, which is our g of x. And last one, h of x, which equals 2x squared minus 4x minus 3. Plugging in our values, when x is negative 2, 2 times bracket negative 2 squared minus 4 times negative 2 minus 3 gives us 13. And then negative 1, I'm just going to change this one. Wherever I have a negative 2, I'm going to put a negative 1 instead. So 2 times negative 1 squared minus 4 times negative 1 minus 3 gives us 3. And then we put zeros, which would make the first two terms 0, so then we'd have negative 3. And then we put positive 1, which would make the first term 2, and the second term negative 4. And we get negative 5. And then if we put positive 2, we get negative 3. Let's plot those points. When x is negative 2, y is 13. When x is negative 1, y is 3. When x is 0, y is negative 3. When x is 1, y is negative 5. And when x is 2, y is negative 3. So we can see it's also quadratic. We see that the points 0, negative 3, and 2, negative 3 are symmetrical. So that would mean that halfway between those points, when x equals 1 and y is negative 5, that would be our vertex. So we can also plot another point on the right side that would be symmetrical from negative 1, 3. So it is 2 units left of the vertex and 2, 4, 6, 8 units up. So 2 units right of the vertex and 2, 4, 6, 8 units up. So right across from the point negative 1, 3, but at positive 3, 3, symmetrical. And we can draw our parabola. And that is h of x. part D, how could you use the values in the columns from f of x and g of x to determine the values in the column for h of x? H of x is the sum of the functions f of x and g of x, and if we look at the columns for f of x and g of x, 5 plus 8 would equal 13. 1 plus 2 equals 3. Negative 3 plus 0 equals negative 3. Negative 7 plus 2 equals negative 5, and negative 11 plus 8 equals negative 3. So we could add the y values of f of x and g of x to get the y values for h of x. State the domain and range for f of x, g of x, and h of x. F of x is a linear function. Our domain for linear functions is x such that x is an element of the real numbers. And the range is the same, y such that y is an element of the real numbers. G of x is a quadratic. Domain is x such that xer for all quadratics. And the range is defined by the vertex, which in this case was at a minimum value of y equals to 0. So y is greater than or equal to 0, y-e-r. H of x is also a quadratic. The domain is then x such that xer. And the range again is defined by the vertex, y such that y is, in this case, greater than or equal to negative 5, y-e-r. And last part, determine the values of f of negative 4, g of negative 4, and h of negative 4. F of negative 4, the function f of x is negative 4x minus 3, so negative 4 times negative 4 minus 3, which is 16 minus 3, which is 13. And then g of negative 4, g of x is 2x squared, so 2 times negative 4 squared, which is 2 times 16, which is 32. Then h of negative 4 equals f of negative 4 plus g of negative 4, which equals 13 plus 32, which gives us 45. Consider the function f of x equals the absolute value of x and g of x equals x minus 5. Determine the equation of the function h of x equals f minus g of x. H of x equals f of x, which is the absolute value of x, minus g of x, which is x minus 5. With subtraction, we can't just drop the brackets. We have to multiply the negative into the brackets. So we get h of x equals the absolute value of x minus x plus 5. Sketch the graphs of f of x, g of x, and h of x. Starting with f of x, the absolute value of x at 0, the absolute value of 0 is 0, 1, absolute value of 1 is 1, absolute value of 2 is 2, and so on. And then for negatives, absolute value of negative 1 is positive 1, absolute value of negative 2 is positive 2, negative 3 is positive 3, and so on. So we get a V shape for f of x. G of x is x minus 5, so slope of positive 1, and a y-intercept of negative 5. Slope positive 1 means up 1, right 1, up 1, right 1, up 1, right 1, and so on. And we get this for our g of x. And then h of x, we can use this table here. H of x is the absolute value of x minus x plus 5. If we sub in negative 2, absolute value of negative 2 minus negative 2 plus 5 equals, can use our calculators. For the Casio calculators, to get absolute value, you push option, and then you push F6 to go over to see more options, and then you push num, which I think is F4 in most cases, and then you push F1. It says ABS. In a TI, we push math, we go over to num, and then it's number 1 ABS. So we put in negative 2 in our absolute value, get out of the absolute value, minus bracket negative 2, close bracket, plus 5, and we get 9. Then we repeat that process for negative 1, so I'm just going to edit this one, change my negative 2 to negative 1, and absolute value of negative 2 to negative 1, and we get 7. And then if we plug in 0, the first term would be 0, the second term would be 0, so we would have plus 5 left. If we put in a 1, we get 5 again. And then if we put in 2, we also get 5. Can plot the points. X is negative 2, y is 9. X is negative 1, y is 7. X is 0, y is 5. X is 1, y is 5. X is 2, y is 5. So our graph has a part that is decreasing from left to right, and then it becomes a horizontal line after x equals to 0. State the domain and range of f of x, g of x, and h of x. F of x is an absolute value function. The domain is x such that x, e, r. The range is all y values greater than or equal to 0. Y such that y greater than or equal to 0. Y, e, r. G of x is a linear function. Domain would be x such that x, e, r. And the range would be y such that y, e, r. And then our h of x is a combination of the two. It continues going left and right forever, so our domain is x such that x, e, r. Our range, the graph never goes below y equals 5, so y such that y is greater than or equal to 5, y, e, r. Part D is the function f minus g of x equal to g minus f of x. Explain. Thinking about subtraction, is 3 minus 5 the same as 5 minus 3? No. One of them is positive 2 and one of them is negative 2. They're not the same. So same applies for functions. The order of subtraction makes the difference. So no, functions are not the same because the order of subtraction matters. For example, 5 minus 3 equals 2, which is not equal to 3 minus 5, which is negative 2. Summary. The sum of two or more functions can be found by adding the y-coordinates of the functions at each x-coordinate. This also applies to the difference of functions. So what that's saying is, if you don't even know the equations of the functions, but you're given the graph of f of x and g of x, and you're told that h of x is f of x minus g of x, then you can take what is the y value here, which is 2, and subtract the y value here, which is negative 3. 2 minus negative 3 gives us 5. So you can plot the point for h of x without even knowing what the functions are, just by using your graphs. Same with the next point. Let's try when x equals 4, y equals 4 on f of x, subtract y equals negative 1. 4 minus negative 1 is 5. So we plot h of x is 5 when x equals 4. The domain of the sum or difference of functions will include the domain of the original function. So we saw in our two examples, all of our domains were the same. They were all XER, all real numbers. If the domains of the two original functions are not the same though, then the domain of the new function will be the more restricted of the two domains. And then the range of the new function can be determined from the graph. Let f of x equal x plus 1 and g of x equal the square root of x minus 4. Write the equation of each combined function and determine its domain without using your calculator. F plus g of x would be f of x is x plus 1 plus g of x is square root of x minus 4. And because it's addition, we can just drop those brackets. So we get f plus g of x equals x plus 1 plus square root of x minus 4. For the domain of f plus g of x, we need to look at the domains of the original function. F of x is a linear function, x plus 1, so the domain is XER. G of x is a radical function, and we know that radical functions, the radicand, the part under the root, has to be greater than or equal to 0, because it's a square root, can't have a negative number under the square root. So we know that x minus 4 has to be greater than or equal to 0, which would mean that x has to be greater than or equal to 4. Then for the combined function, the more restrictive of the two domains is x greater than or equal to 4. So that would be the domain of this function, x such that x is greater than or equal to 4, xer. The next one, the difference of the two functions, g minus f of x. So g of x goes first, the square root of x minus 4, and then minus x plus 1 in brackets. We multiply that negative into the brackets, and we get g minus f of x equals the square root of x minus 4 minus x minus 1. And again, we're using the same functions, f of x and g of x. The domain of f of x is xer. The domain of g of x is greater than or equal to 4. So our domain for the difference of these two functions is again x such that x is greater than or equal to 4, xer. And we can write ourselves a note here of the domains of f of x and g of x. X greater than or equal to 4 is more restrictive than xer. So the domain of the combined functions f plus g of x and g minus f of x is x greater than or equal to 4. Sketch the graph of the combined function indicated, given the graphs of f of x and g of x below. H of x equals f plus g of x. So we want to add our y values together. When x equals to 0, f of x is negative 5 and g of x is 0. Negative 5 plus 0 is negative 5. So our new function h of x will have a point at 0, negative 5. X equals to 1. Our f of x and g of x are the same. They're both negative 2. Negative 2 plus negative 2 is negative 4. So our new graph, h of x, will have a point at negative 4, which is negative 2 minus negative 2. When x equals to 2, f of x is 1, and g of x is negative 4. 1 plus negative 4 is negative 3, so our new graph, h of x, will have a point at x equals to 2, y equals to negative 3. And then when x equals to 3, f of x is 4, and g of x is negative 6. 4 plus negative 6 is negative 2. So our new graph, h of x, will have a point at x equals to 3 and y equals -2. And then we can join those points together to draw the graph of our new function h of x, which just has a, as we can see, it has a y-intercept at -5, and it has a slope of 1. It's going up 1, right 1, up 1, right 1, up 1, right 1, and so on, which would also mean down 1, left 1, down 1, left 1. So there's our graph h of x. I'm just editing this and realized that for some reason I was writing f of x minus g of x, even though I was calculating and saying f of x plus g of x. So these should be -2 plus -2, 1 plus -4, and 4 plus -6. Next one, h of x equals f minus g of x. We're doing subtraction now, so we have to make sure that we find the y value of f of x first, and then subtract the y value of g of x. F of x is a quadratic. We need to make sure we get the number from the quadratic first, and then subtract the number from g of x, which looks like an absolute value function. Starting with x equals to -4, f of x is 8, and g of x is 4. 8 take away 4 is 4. So our h of x will have a point at x equals -4, y equals +4. Then the next time I see my quadratic where I can read a point is at x equals to -2, and at that x value, the y values of the two functions are the same. They're both 2. 2 take away 2 is 0, so our new function h of x will have a point at x equals -2, y equals 0. The next point I can read on f of x is when x is 0 and the y value is 0, and for g of x the y value is also 0. 0 minus 0 is 0. So again we have a point at x equals to 0, y equals to 0. Next one is when x equals to 2, f of x equals 2, and also g of x equals 2. 2 minus 2 is 0. So again, we have a point when x is 2, y is 0 for h of x. And then for f of x, I have a point at x equals to 4, y equals to 8. And on g of x, when x equals to 4, y equals to 4. 8 take away 4 is 4. So h of x will have a point at x equals to 4, y equals to 4. And then I could almost combine them, but I don't really know exactly what's going on here. So I want to take another look at my graphs. So I can look at this point. Let's say that we know that x equals 1 here. And let's say that y is about 0.5. And here on g of x, we have when x equals to -1, y is +1. So if we take our y values and subtract them, f of x first, right? So 0.5 subtract 1 would give us -0.5, which tells us that on h of x, when x equals to -1, y equals to -0.5. We can do the same on the right side between these 2 points. If I look at x equals +1, the f of x value is about 1/2, and the g of x value is 1. So starting with f of x, 1/2 or 0.5 minus g of x, which is 1. So 0.5 minus 1 would give us negative 0.5. Then that means on h of x, we have a point at x equals 1, y equals negative 0.5. 0.5 minus 1 equals negative 0.5. So then we can join our points together. So these points join, we get a bit of a vertex there, and then we get another vertex. So it's kind of like two quadratics that have been fused together. Just gonna highlight it because it's kind of hard to see. That is our h of x. Use the graphs of f of x and g of x below to evaluate the following. G of negative 4. G of negative 4, x equals negative 4, go up to g. G of negative 4 is when y equals to 5. So it equals 5. F of 0, the function f when x equals to 0, go up to f of x, and we have that y is 2. F plus g at negative 5. Start at x equals negative 5, go up to f, which gives us a value of 3. Then from negative 5, go up to g of x, which gives us a y value of 6. And then we're adding those y values together, so it equals 3 plus 6, which equals 9. F minus g at 3. X equals to 3, go up to f of x, which is the solid, the darker line. That gives us a value of y equals to 1. And then subtract the y value when x equals 3 at g of x, which is 2. 1 take away 2 is negative 1. G minus f at 4. Looking at x equals to 4, first we want g. G has a y value of 3 when x equals 4. So we have 3, and then minus the x value of f when y equals to 4 is 0. 3 minus 0 is 3. And then f plus g of 5. Well, if we look at x equals to 5, f of x does not have a value at x equals to 5. It stops at x equals to 4. So we can't possibly add f plus g at 5 because f of x has no value for when x equals to 5. So we would just say this is undefined because f of 5 does not exist. Let f of x equal the absolute value of x and g of x equal 5. Write an equation in terms of x for each of the following. Y equals f of x plus g of x would give us y equals f of x is the absolute value of x plus g of x is 5. Second one, y equals f of x minus g of x. Y equals f of x is absolute value of x minus g of x, which is 5. And then y equals g of x minus f of x. Y equals g of x is 5 minus f of x is absolute value of x. Part B, explain how you could produce each of the functions in A by applying transformations to the graph of f of x equals absolute value of x. So the first one, y equals absolute value of x plus 5. That would be a k value of 5. So this is a vertical shift up 5 units. So if we started with absolute value of x and then we shifted it up 5 units. The second one, y equals absolute value of x minus 5. That's a k value of negative 5. So this is a vertical shift down 5 units. And the third one, we have y equals 5 minus absolute value of x. I'm going to rewrite this as y equals negative absolute value of x plus 5. Then we see that this is a reflection across the x-axis because we have an a value of negative 1 and a vertical shift up 5 units. We have a k value of positive 5. A communications company manufactures a mobile phone for $25 per unit plus a fixed operating cost of $45,000. The mobile phones are sold for $100 per unit. Determine a function to represent the cost, C, of producing n units. So cost, C of n, the cost function based on the number of units, would equal, it costs $25 per unit, so 25 times the number of units, plus the fixed cost of $45,000. Determine a function to represent the revenue from sales of n units. So revenue function based on n units equals, how much are they selling for? The mobile phones are sold for $100 per unit, so the revenue would be 100 times n, the number of units. Part C, determine a function to represent the profit, P, from sales of n units. Profit is equal to the revenue minus the cost. So profit, P of n, equals revenue, R of n, minus cost to make the product, C of n. Then P of n equals 100n minus 25n plus 45,000. Make sure that that second function, C of n, is in brackets. We need to multiply the negative into the brackets. P of n equals 100n minus 25n minus 45,000, and then combine our like terms. P of n equals 100n minus 25n is 75n minus 45,000. D, what is the break-even point for the manufacturer of these cell phones? Break-even point, that means $0 profit. So at what point do they just make enough money to cover their costs, but don't make any extra money? So we want to know, when is profit equal to 0? So 0 equals, our profit function is 75n minus 45,000. And we want to solve for n, add 45,000 to both sides. We get 45 1,000 equals 75N, and then divide by 75. $45,000 divided by 75 is 600. N equals 600. Therefore, they need to produce 600 units to break even, which means they get 0 profit, but they cover their expenses. That brings us to the end of Chapter 10, Lesson 1.